Remember that this is our heavy line. That is the distinction between metals and nonmetals. Like such. And these ones that are written in brown here, those are our semi-metals. Everything above here are nonmetals. And everything down here below the line are metals. What are properties of metals?
Solid.
They're solids, except for this guy right here. Yes?
They conduct electricity.
They conduct heat and electricity. So these guys are conductors. These guys are insulators. These metals are shiny, ductile, malleable. Non-metals are dull, brittle. Metals are conductors. Non-metals are insulators. And we also went over the fact that this is the atomic number that tells us the number of protons. And underneath is going to be the atomic mass number, which is the number of grams in 1 mole. The concept of a mole is super important in chemistry class. So if you don't remember what a mole is, I did post the link to a video reviewing what a mole is. But in a nutshell, a mole is a counting number. So we all know when we say the word dozen that we mean 12. So a dozen donuts is 12 donuts. A dozen eggs is 12 eggs. 1 dozen cats, 12 cats. A mole is the same thing. A mole is 6.02 times 10 to the 23rd of anything. And remember how huge that number is. So in the video, I actually expanded out and you can see how big that number is. It is so big that every man, woman, and child could spend $1 million an hour for their entire life and still have most of it left over. Every man, woman, and child on the planet, if you had 1 mole of pennies. That's a lot. It's a huge number. So 1 mole of any substance, like 1 mole of calcium, or 6.02 times 10 to the 23rd atoms of calcium, has a mass of 40.08 grams. So let's review molar mass. I'm just going to come up with a compound. This particular compound is calcium carbonate. That's calcium carbonate in my little tube over there. Calcium carbonate is like anytime you see white rocks, a lot of times they'll be calcium carbonate. Might also be called limestone. Chalk is oftentimes made out of calcium carbonate also. So it's a substance we see all the time. Its chemical formula is CaCO3. So this, every 1 mole has 1 mole of calcium atoms that have a mass of 40.08 grams. 1 mole of calcium carbonate has 1 mole of carbon atoms with a mass of 12.01 grams. And 1 mole of calcium carbonate has 3 moles of oxygen atoms. Each of them have a mass of 16.00 grams. So in order to get the molar mass, I would add all of that up. So it'd be 40.08 plus 12.01 plus 3 times 16.00 grams. And you add that up, and the mass of 1 mole of calcium carbonate is 100.09 grams. Anytime you're using your periodic table of the elements, significant figures wise, we're just going to go 2 past the decimal and we'll call it a day. We're going to be good with that for significant figures. Let's try one more. And this is aluminum with a mass of 26.98. This is why aluminum is so amazing, is because look at it next to all the other metals. It is one of the lightest metals. You can see there's some lighter metals like lithium and sodium, But lithium and sodium, you can't even hold in your hand. They're so reactive, if you tried to hold lithium or sodium in your hand, it would burn right through your hand. So aluminum is a stable metal that is super light. And actually, believe it or not, they were not able to get aluminum away from oxygen, because aluminum and oxygen love each other, until fairly recently, like late 1800s. They couldn't get it into production until well into the 1900s. So aluminum foil and aluminum cans and aluminum airplanes are fairly recent in history. Does anybody have any in their family who still calls it tinfoil? I still call it tinfoil, but probably none of your parents have even seen tinfoil. It's just something that people do. It used to be made out of tin until about 1964. They stopped making tinfoil. Can anybody guess why they use aluminum instead of tin now? It's cheaper. It's always money. So tin is more expensive metal, and aluminum is a cheaper metal. Once they figured out how to get it away from oxygen, they used to think aluminum was pretty rare. They actually used to make like crowns out of it stuff. They thought it was a rare metal because they couldn't get it away from oxygen. They didn't have the technology to get away from oxygen. Okay, let's do another compound, and we'll do the molar mass. Aluminum nitrate. This is the compound aluminum nitrate, and these parentheses actually mean this. The aluminum has 3 nitrates attached to it. If you think about it that way, it'll help you from making some common mistakes. And the common mistakes are to forget that it's 3 times 3, or 9 oxygens, not 6, and 3 times 1, or 3 nitrogens. So we kind of sometimes forget that we're multiplying, and sometimes we forget that the subscript outside the parentheses belongs to all of the elements inside. So aluminum off the periodic table of the elements is 26.98. Nitrogen is 14.01. Oxygen is 16.00 grams. This is all how many grams there are per mole. That's what the periodic table of the elements tells you. So we have 1 aluminum at 26.98 grams. We have 3 nitrogens at 14.01 grams. And we have 9 oxygens at 16.00 grams. For a molar mass of a whopping 213.01 grams. So we all good on molar mass? That's coming back to us? Okay. Let's add one more, and then we'll do some practice. We're going to add percent composition. The formula for percent composition, or really percent of anything, is part over whole. So we want to do the part over the whole, which in this case is always going to be 100.09. And then to turn it into a percent, we multiply by 100. So the percent calcium is going to be 40.08 over 100.09. So 40.04% is calcium in this compound. Percent nitrogen, we'll do exactly the same thing. The part that's nitrogen, the whole compound of 100.09. When I round it to 2 sig figs, I get 12.00 grams, percent carbon. Now here's where we have to be careful, because this is not 16 grams. It's 3 times 16 grams of it is oxygen. Now, who's got their thinking cap on? If I've done this correctly, what will my percentages add up to be? Should add up to be 100. Now, some cases, because we rounded, might get a little bit off of 100, a little bit more, a little bit less, but you expect it to be 99.99 or 100.01, something like that. That's acceptable because of the rounding. That's how things happen. Let's do the same here. So the percent aluminum is the part that's aluminum over the whole compound times 100. Rounding rules are the same as in math class. Now I want to point out too that because in chemistry class we're using really big and really small numbers, we need to use the exponent function on our calculator. So if you have a calculator that you intend on taking to college, bring it to class every day so I can make sure you're using it correctly. Now remember, this is 9 pieces of oxygen on this compound. Therefore, it's 67.60% oxygen. So there's a review of molar mass and percent composition that we're going to need to use in our lab. Now, if you notice, both these compounds had oxygen. Oxygen's actually a super reactive nonmetal. Oxygen's all over the place, and oxygen loves to react, especially with metals. So oxygen is O2 when it's found in the atmosphere, but he really likes to react with whatever he comes across, which is good for us because when we breathe the oxygen into our lungs, that reaction happens without us even having to think about it, and we never have to worry about running out of oxygen as long as we're not in a closed space.